Hello and welcome to day 4 of Algebra 1 Semester 2 Summer School. Today's main target is to be able to use exponent rules to simplify algebraic expressions. So part of what we're going to do today is look at the exponent rules and how they work. I'll do some examples and you'll have some independent practice to do before you take the formative assessment. So let's go ahead and get started with powers of monomials. If you have a monomial means single term. So mono means one, nomial means terms or parts. So if you have a monomial, you're looking at one term. And if we're raising that one term to a power, we're going to use the power rule. And basically what happens is we're going to take our exponents and we are going to multiply them together. Now, the reason that happens, let's take a look at an example here of, let's do CD squared to the third power. When you're using exponents, exponents mean repeated multiplication. So, if I take CD squared to the third power, that means I have 3 sets of CD squared being multiplied together. All of the C's become multiplied together, all of the D squareds multiply together, and then we can combine. So that would be C to the third power and D to the 2, 4, 6 power. Which is why we would multiply those exponents together. Notice that the C really is missing an exponent of 1. So this would be C to the 1 times 3 is 3. D to the 2 times 3 is the 6th power. Okay, let's take a look at example number 2. Basically what's going to happen is we are going to multiply both exponents by 4. So this becomes m to the 7 times 4, which is m to the 28th power. N to the 4 times 4 would be n to the 16th power, and that would be the expected answer for that question. If you have coefficients with your number, those are constants, numbers, regular numbers being multiplied in front of the variables in your expression. You want to raise the coefficient to the given power and then simplify the variables with the power rule. So basically that 5th power is going to have to go to the 2 and the x squared and the y. So this becomes 2 to the 5th power, x to the 2 times 5 power, and y to the 1st power. 2 to the 5th power with constants, you could just leave it, and then x to the 10th and y, or you can evaluate that 2 to the 5th power. 2 to the 5th power means 2 times 2 times 2 times 2 times 2. It means to take that 5 times, which is 32, x to the 10th, y. That would be the most simplified version, although this version of that number would also be acceptable. And sometimes you get to numbers that are just really, really big, and so it's easier to leave them as an exponent instead of as a simplified number. You want to be very careful when you see negatives, because that negative also has to be part of what you're simplifying. So make sure you use parentheses if you're going to use your calculator. Basic idea is if it is an odd exponent, your answer is going to stay negative. If it's an even exponent, you're going to end up with a positive answer. So negative 3 to the 3rd power would be negative 27. And then x, 2 times 3 is 6. Okay, there are 4 problems on this page that you're expected to complete. Problem number 1, number 4, 7, and 12. That's the independent practice for powers of monomials. You can either pause the video now and do that, or you can come back after completing the rest of the notes. All right, the next rule that we're going to look at is dividing monomials. So now what we're going to use is called the quotient rule. Notice that we're dividing the bases. So we have x to the a divided by x to the b. What happens here is we subtract those exponents from each other. What really happens is if we had x to the 5th over x to the 3rd, that means we have 5 x's multiplying together on top, 3 x's multiplying together on bottom, and we get some expressions that reduce to a value of 1. And we're left with 2 x's on top. So we're really looking for the difference in the number of x's, or the number of terms on top and on bottom. So that's why this would be x squared as our final answer. So let's look at example number 2. We have k to the 12th power divided by k to the 2nd power. So we are going to subtract the exponents, which would give you k to the 10th power. On number 5, notice we've got 2 different bases happening. We've got p's and q's. You can only subtract exponents from the same term, or the same type of term. So only the p's can subtract, only the q's can subtract. So this would be p to the 7 minus 4, and q to the 16 minus 12. 7 minus 4 is 3, 16 minus 12 is 4. So that would be the expected value there. When you have coefficients, you want to divide the coefficients, treat them like you normally would, and then use the quotient rule for the variables. So we have 14 divided by 7. 14 divided by 7 is 2. Then we have r squared minus 1. So notice that these would be the first exponents down here. And then s 2 minus 1. So this would be r to the first power, which is just r, and s to the first power, which is just s. Okay, notice in number 11 that the larger coefficient is in the denominator, so this is where you would reduce your fraction. 4 and 8 are both divisible by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. So the coefficients reduce to 1/2. Then we can take our n and we can subtract our exponents. So this would be 1/2 n to the 4th power, which could be written as n to the 4th over 2. All right, on this page, again, you have 4 problems, 4, 7, 10, and 13, that you need to do for independent practice. You can either pause the video and do them now and then come back for the next rule, or you can wait until the end before you take your summative or your formative assessment. Okay, the next rule we're going to look at are negative exponents. Negative exponents can be written using positive exponents using the negative exponent rule. And the negative exponents means we want the reciprocal of the term that we're looking for. So we want to take 1 over that value. Really what's happening here is if we had x to the 3rd over x to the 5th, one way to simplify this would be to subtract those exponents. And if we subtract those, we end up with a negative exponent. If, however, we look at this in terms of its repeated multiplication, 3 of those exponents, or 3 of those terms, reduce, leaving a 1 on top and x squared on bottom. which kind of gets us to that rule that we were talking about there, where it's the reciprocal. Notice that after you take the reciprocal, the exponent becomes positive. That's how we can work with that piece of information. So let's look at a couple of examples. The coefficient's going to stay by itself. We're just going to leave -7 alone. Now notice that the a is the only piece with the negative exponent. So I'm just going to draw a fraction bar, and then I'm going to move that a to the 4th and put it on the bottom. And b to the 3rd stays on top. One way to think about it is that if you have that negative exponent, it means it's in the wrong part of your fraction bar. So if it's on top, it goes to bottom. If it's on the bottom, it goes to the top. So that would be the simplified form of that. Let's look at number 6. When you have two terms being multiplied together, we want to multiply the coefficients together. So 6 times -3. And then we can put the variables together. 6 times -3 is -18. We're multiplying the bases, so we add the exponents. -8 minus 3 is -11. That negative exponent means it is unhappy in the position it's in, so it needs to move to the denominator of that fraction and become a positive 11th power. Okay, if we look at number 9, we can use that power rule, and we have 5 to the -3rd power and y squared times -3, which would be 5 to the -3rd power and y to the -6th. Both of those are negative exponents, so we're going to make a fraction bar. We're going to put 1 on top, and then we're going to put 5 to the 3rd and y to the +6th on the bottom. If we multiply 5 to the 3rd out, that's 125. Either of those would be appropriate answers. All right, I've got a couple for you to try on this page, number 2, number 4, and number 8. Once again, you can either pause and do those now before you move on, or you can come back at the end and complete them before moving on to the formative. All right, so now let's summarize our exponent rules. This becomes a great page for you to come back and look at, to review and to express the things that are happening. So when you are adding and subtracting monomials, this is where you combine like terms. Do not change the common variables and do not change the exponents. And in order for them to be combined, both the variables and the exponents have to match. So I would take 9 minus 10 x squared y. So we're just combining the coefficients there, and then the variables and exponents stay the same. So this would be negative x squared y. I'm going to leave the evens, the number 2s, for you to try as part of your independent practice today. So you can do those as we go or before you turn it in. For the product rule, we want to take and add the exponents together. So when we multiply the bases, we add the exponents. So in my example over here, we would take our exponents of 2 and 6 and add them together to get h to the 8th power. I'll leave you number 2 as an example. Power rule. When we are taking a power to a power, we multiply the exponents together. So I would take x to the 2 times 3, which would be x to the 6th power. For the quotient rule, when you are dividing the bases, you subtract the exponents with the numerator on top in front and the denominator behind. And with the constants, you would reduce your fractions if possible. 27 and 42 are both divisible by 3. 27 divided by 3 would be 9. 42 divided by 3 would be 14. Then we would take our variables, and we have the fifth power on top and the first power on bottom. So this becomes 9x to the fourth over 14. Negative exponents are the reciprocal. And notice that it only goes to the term it's connected to. So the negative 5 is going to stay in place, and then x to the positive second power is how we would move that, take care of that negative exponent. Now we haven't talked about this one yet, but the 0th exponent gives you a value of 1 always. So if you have any number to the 0th power, it's just 1. So if we take 7 times x to the 0th power, that's really just 7 times 1, which is 7. All right, that's our lesson for today. Remembering these exponent rules. This page makes a great set of notes. You might have this page open as you're working through independent practice, and I definitely recommend having it while you do your formative. Good luck. Thanks for your hard work today. We'll talk to you again.